Get started. Adrian, thanks for being here. We're really excited to kick off for this fireside on scaling principled games. It's good to see you. And I want to give you a little context on just kind of like who's here in the room and kernel, um, and the topic of the week. We're trending towards the latter half of a kernel block. We go through 9 weeks, and this is the sixth module, so we're kind of like turning the corner. How the syllabus works, I think you'll start to see quickly why we wanted to have you here for this moment in the syllabus. We think that the work that you're doing is functionally at this part of what we see. So how the syllabus works is you kind of start with an introduction. We have an introduction to kernel, but also an introduction to Bitcoin. You have like an early Andreas Antonopoulos talk on peer-to-peer money. It kind of goes through what Bitcoin is, the foundational ideas of trust and where that comes from. Then in module one, we go through Ethereum. So Ethereum's history and state. You have a lot of the early writings around Ethereum, very fun DEFCON 1 talk from Vitalik with the Swiss Army knife meme. Then you get to the global financial system, starting to think about it both broadly in terms of people like David Graeber, who's written Debt the First 5,000 Years, and again, back to Antonopoulos into like what are the properties of money that we're coming back to discussing and exploring. Take Back the Web, the big narrative around Juan Benet's work, The Graph, Filecoin, Arweave, that kind of comes out of the global financial system work. And then we start looking ahead. Last couple weeks for internet age institutions. You have some thoughts on governance. We kind of flip that one and explore governing yourself. The liberal radicalism stuff and radical explorations of internet institutions, like what could internet institutions look like. Begin our forward look. Tokens was last week. We went through tokens and mechanism design. A hard one to cover in 1 week, but we gave it a go, and we went through games and game design and effectively like how can we see mechanisms evolving. And that brings us to week 6, which is scaling principled games. And I think, Adrian, you've been really succinct about this, and you offer a particular perspective on one particular principled game. And I want to get into that, but I'll just kind of outline the module for everyone. Each week, as always, there's a kind of like an external reading and then a more internal one. This external reading is on censorship resistance. And it starts by saying it's critical to speak truth to power. History is proof of this. However, history also shows how the existence of any kind of power structure influences what truths can be thought in the first place. Influences what truths can be thought in the first place. How can we free ourselves from this constraint? So our approach to talking about censorship resistance is somewhat tied to the kind of like broad global exploration of the term as it's usually talked about. It's nation state level refusal or creative refusal of the current systems that are in place. But in this module, there's also a suggestion that it is an internal process to not self-censor. And that is a big part of like the learning process. And so the learning how to learn module, it's probably like our simplest one in some sense. It's like, how do we discuss and reason about like the process of learning? And we whittle it down to 4 things. You can talk about it in a multitude of ways, but we say it's a sincere desire to know, a determination to practice what you know consistently, a passion that will not let you stop until you know, and a heart clear enough to know its own intention for pursuing knowledge at all. It becomes like really relevant to kernel, which is obviously like an educational environment. It suggests that the current search for new educational funnels must be reversed into the institutional inverse, which is educational webs, which heighten the opportunity for each one to transform each moment of living into one of learning, sharing, and caring. And I hope that this hour is just kind of indicative of it. The last thing I want to point out, there's some really good stuff in the curated materials, as always. There's kind of like a deep dive on like some of the like seminal resources that led to Ethereum 2.0. You have an early Serenity design rationale point, why there was a layer one versus layer two trade-off. This hasn't been touched in 3 years, but we like leaving it as an example of like, okay, this was what the resource was when that type of decision was being made. And at the moment, when we kind of first got this syllabus together, this was the big topic. It was, can we get to an Ethereum 2.0 roadmap? What is the trade-off between L1 and L2? How do we continue down this virtual machine-based approach to scaling blockchains and making them more, let's say, energy efficient, having all sorts of benefits. But ultimately, it kind of continues down this specific trend of virtual machine. And I think Adrian's going to help us see how like the game of blockchains is very much evolved in the last 2 to 3 years, and some of the work he's been doing has been in that direction. The last one I want to explicitly point out is that there is a new brief that we put together here, a lot of research coming out of the Flashbots community. There's a lot of this stuff kind of at the cutting edge of crypto and AI, but the Flashbots folks have thought about this crypto and AI stuff as kind of a extension of the work that they've been doing in MEV. And so it's one of our more complex briefs, but it talks about credible commitments, architectures of participation, and ultimately the suggestion is that we have like a privacy requirement to make blockchains and LLMs most beneficial. And so I don't know how much we'll get into it with Adrian. I'm curious if he'll end up having thoughts, but I wanted to kind of like set the stage a bit here today. So censorship resistance and learning, but ultimately the topic is scaling principled games. And really grateful to Adrian for taking the time out. His work on Anoma and Namada have been influential in my crypto experience. I remember first talking to Awa, one of the other founders of Anoma at ETH Denver in, I think, 2021. And she was bringing up this idea of like a local state first machine that also could go back to some type of global state. And there would be a way for both things to be equally possible, but that the local state would be emphasized. And this felt very intuitively interesting, but also foreign as a concept at the time, because you only had global state as kind of like an option that was being expressed and could be expressed really within the Ethereum context of we are all going to agree on global consensus. That's like kind of like a built-in nature of it. So to hear somebody talk about this like local first option, or maybe I think Adrian likes the word like the sovereign option, and still have the global, it was interesting, compelling, but also just like kind of like, oh, this is curious. I'm not sure exactly where it's going to go. But it has evolved, and there's been great work in the privacy space that has been required to make it happen. And Adrian now co-leads Anoma and Namada. And I hope we'll get into both. But first, I just want to, welcome Adrian. His work has spanned many parts of the blockchain space, starting with the Cosmos ecosystem into being one of the first stakers before proof of stake was really a guarantee of any kind, and onwards into really like building better distributed systems, into deep cryptography work, into exploring a lot of the deeper natures of distributed systems. And so I guess the first question, Adrian, if we could start well, is just like, how have you seen this scalable game of blockchains evolve? What have you learned as we moved from, let's say, Ethereum onwards into the next things?
Yeah, actually, so as a funny aside to start with, maybe, I actually started with Ethereum because I wrote my grad thesis in 2016 on censorship-resistant e-voting on Ethereum because nothing else like had the programmability capabilities to do this. And I mean, this sort of like comes very much also from like Jody's background. I was pretty curious about the Catalan independence movement at the time. I was like, hey, we could be using Ethereum here to build actually censorship-resistant e-voting solutions, so the Catalan people could run elections based on passports, so that certify where they live, um, without the Spanish state being able to interfere. And actually, only through that did I then end up in Cosmos in this many blockchains world. Um, so maybe scalability, right? Like I think so. I come from a very different perspective because um, like I'm trying to. I think we should make blockchains work for the real world, and sort of like one way I like to think about Anoma is as a scale-free model. It is because right now we're all trying to solve the problem of like how do we have a lot of synchronous global state, right? Like when you really think of what Ethereum, the base layer does right now, it's synchronous global state. Um, However, why are we doing this? And so why one of the arguments that becomes, well, it's the most decentralized or the most secure. But then I think the really prominent counterpoint to this is my parents don't consider Ethereum secure. And like there's nothing in the world I can do to convince them of this because it's like it's a fundamental security model that they don't understand. Like if you live in Argentina, this is maybe a better model for you to be secure in, but sort of like security is a fundamental, it's a very human perspective, right? And so they live in Germany. They actually fundamentally want something that the local government, the local courts can override. So to them, this is not the right answer. So they actually want to have some locally sovereign system. And I think especially in Europe, this is much more prominent than especially in the US, because Europe sort of went through the last 20 years of digital slavery to large US megacorps. And so this idea of like, well, we should build the future financial system should still again be like outsourced to some third party system that I don't really understand. I think it's pretty terrifying, right? And so then you start thinking, okay, like if this is not the right security model for everyone, what does it look like from a latency perspective? Well, like if we want to do some localized trading, like I currently am in Zug in Switzerland, like my coffee payments do not need to be globally ordered with coffee payments in New York. It makes zero sense. And so I'm paying for all this cost of like achieving global total order, and I don't need any of it. I also take a huge latency hit because now I have to do essentially what Visa and MasterCard do, which is you ping back to a bunch of servers in probably Connecticut or Virginia. So I don't really know whether, well, definitely through Virginia actually for various other reasons. But so you essentially live in this world where you have to like transmit a lot of data over fiber cables. And so to that point, like Solana always tried to like pitch this idea of like, well, the world's fastest consensus. And like Anoma will always be faster than this. Because you can run Anoma on your phone with the three people that you actually want to interact with. And like you are at that point only bound by speed of light, which even if you, so as soon as you do global consensus, you're now in this world of like, well, it's at least like half a second or so of global consensus if you need to do multiple rounds, right? And so from that perspective, it's also like this local sovereign first approach makes a lot more sense. However, one of the really big challenges with this, right, is that over time, you get this huge fragmentation. And we're seeing this right now, essentially, where, well, my wallet works on X, but not Y. And for some reason, I need to keep porting these 12 words everywhere. And all my applications change all the fucking time. And like the analogy I like to use of why this is really horrific is like imagine like to every country that you go to, you have to buy a new phone, and all of a sudden, all of us keep running around with like bags of 50 phones, and we go like, "Ooh, today I'm in Switzerland, phone A, and tomorrow I'm in Germany, phone B." And the way we actually solve this in the real world is to say, well, it's standardized on the protocols, and then applications can roam, and they can essentially now phones can roam many different security environments. And this is also how Anoma is designed. Like Anoma is an operating system on top of hardware, essentially. And the hardware here is, for example, like Ethereum. You can run Anoma on top of Ethereum. And like if that's the security model that you care about, as in you care about Ethereum security, you just get access to the Anoma applications, the Anoma operating system stack on Ethereum. If you then want to roam into your local trust zone because you're visiting your parents, you can roam and like your state just follows you. It's not like, oh, you have to send a bunch of IBC messages or you have to like download the new wallet extension. It is just like it's a unified stack that can live on many different hardware environments, right? And this is like why I think this is also like the true form of scalability, because we can scale along essentially like cost benefit ratios where you're like, well, I want to have global state, then you have to pay for it. Well, I'm okay with only local state, then you only have to pay for local state. And so you can make this incredibly performant because every single village, every single city can essentially run their own instances. And just maybe as a last thing, or two last points, which is privacy and sort of like how you should think around scalability and like where data lives and like what communities form sovereign systems. Traditionally, we very much think in terms of, like physical things forming jurisdictions, essentially, right? Like a country is a physical thing. And so countries would have their own chains, but don't think about it this way. Think about like cultural proximity. So for example, like the World of Warcraft community should run also its own economic system. Why? Because lots of interactions actually happen. Like there's a ton of interaction within World of Warcraft, and then it makes a lot more sense to co-locate all of that state. So like state that should be co-located like needs to have some sort of like economic connection to each other. It makes no sense to co-locate World of Warcraft with I don't know, like coffee payments. Like, there's very little interaction there. I mean, in the physical world, this applies because we all pay for coffee in Berlin, but so in the World of Warcraft, we all go to the auction house. So you should be like co-located with the other World of Warcraft state. So it's like co-location is not only about physical proximity, it's about cultural proximity very fundamentally. And the second thing, just to touch upon this, is privacy. Privacy overall is a hard thing to achieve, i.e., like what do we use blockchains for nowadays? Most, it's actually to get interactivity going. It's not to send payments from A to B. I mean, there's some of it, and like Zcash kind of with Sapling and with Orchard really solved the idea of like how do I send private payments from E to B, and this is really what Namada does actually. It's just like multi-asset shielded payments. But most of the actual activity right now is like, I want to trade A for B. And so how do you do A for B privately? Well, the answer is you can't really, because in order to do, like, you need to reveal something about your intention. And this is where actually intents and ANOVA come in, where you can very flexibly describe what you want to reveal about your intent. For example, you can reveal what you are interested in, but not who you are. You can reveal everything. You can only reveal parts of what you're interested in. And B, you can select your own network topology, which is to say that you can decide who to send your intent to. I.e., maybe in the first 5 minutes, you only send it to your local solver that you trust because you've known since high school, whatever. And then after 5 minutes, you go like, well, let's make this free for all. Or maybe you say, well, some of these guys are promising me to, like, are running all these solving algorithms in a TE or TDX. And then like you're only encrypting this against the specific TDX for the first 5 minutes. But like fundamentally, you can, maybe this is actually the most fundamental thing about how you should think about a distributed operating system. Like as protocol designers, we are often, I think, under the impression that we can design specific topologies. And really specific network topologies, i.e. like how economic participants structure each other, are a function of their economic interests. It's very hard to design for. And in that sense, I can almost just very topology agnostic. If everyone in the world wants to use Ethereum as a global settlement layer, they can, and it normally works wonderfully well with this. If there's going to be a single server run by the NSA that settles all global commerce, this also works wonderfully well. You should still use ANOMA for this. If you want to have something where you have 50,000 different sovereign systems that all want to cooperate with each other, ANOMA is also the right topology for this. And this is like, I think, sort of the really big unlock. Whereas like in the past, we've always seen systems that are very specific, that are like fixed to specific topologies. And we sort of then like try to kit a bunch of things on like the L2s to like change this topology. And so like ANOMA on the other side is like very much topology agnostic in the sense like it fits the shape you like the economics want it to fit. That's maybe the easiest way to think about it.
Great. Thank you. Thank you. A wonderful place to start. I'll poke in with one very specific one. We don't have to go so deep, but Adam asks the question in the chat on how you prevent double spending without global state. And maybe if you don't mind, I can try with like this coffee example of like, I'm paying for a coffee and you can fill in what I get wrong. This is also an example of my uncensored learning maybe, but I propose an intent to the Anoma network that says that I want a cup of coffee for $5, like in my local, let's say sovereign system. It's like this local coffee shop nearby. If there is like a solver that is local and nearby, they are able to be like the first one called upon. And if they make it happen, and you can clarify my lingo, if they make it happen, then my money is removed from my wallet, and then that solver gets some type of reward for making it happen. If they fail to solve it, maybe it goes to something that's a bit more global. And regardless, once state changes once, like I guess I don't really have the answer in the double spend part. Maybe you can help with that part.
Yeah, so it makes sense to send it to local servers first, right? Like, because again, latency actually matters in the real world. And like doing a bunch of global interactions is like expensive and has high latency cost. With regards to, but like your intent not only describes, for example, that you want some coffee, it also describes like you have some ETH that you would like to pay with. And that ETH is currently in a specific security domain, or what we call consensus instance. You can think of this way. And generally, actually, let me step back one step. Like when you think of assets, and this applies to even national fiat, there's always like one consensus instance that's allowed to issue more of this asset. In the case of Ethereum, in the case of ETH, it's Ethereum. In the case of the US dollar, it's the US government, right? In the case of the Swiss franc, it's the Swiss government. So like very fundamentally, that's like the origin zone of the asset. But then you can also take like a US dollar or an ETH to some other system. That other system can't really issue new ETH, but it can sort of authenticate the chain of how this ETH moves around. And at some point, this can flow back to original Ethereum, but it doesn't even have to. And so when you think about how do you prevent double spend in global, without global consensus, it's that individually the consensus instances, unless they're the issuer of the asset or the controller of the asset, when you move some ETH from Ethereum, you essentially like delegate the ability to move the ETH, but not the ability to create the ETH. So for example, when you move ETH from mainnet Ethereum to sort of some local Anoma instance, you now have a subcontroller. And so this subcontroller now controls that this isn't double spent. And this is actually where ZK proofs come in really handy, because all of Anoma is one large ZK rollup, or it's a ZK proof. So if we want, over time, we can even post essentially proofs of correct execution back to Ethereum, so that there wasn't a double spend. Or we can use some consensus like light client-based systems like IBC and Common BFT or Tendermint, right? So all of these models still work. But so then the ETH can only exist ever in like one ETH can only exist in a specific instance, right? Like unless Ethereum double spends it. So like imagine there's only one ETH in existence. Ethereum then moves that control to a subcontroller, like the local Zook instance. And then in the local Zook instance, you are sort of like the Zook instance has to make sure that it's not being double spent, because it actually only ever owns one ETH. If there's already now two ETH, we have problems. When you come to sort of the problem of like, and this is sort of the simple problem. This is like how you prevent double spending in a simple way. If you want to have complex block trades, imagine there's the New York Stock Exchange and London Stock Exchange, and you want to do like a synchronous block trade. This is something we have a consensus system here called Chimera Change, and it's part of the Typhon consensus system. Essentially, two chains can become on-demand sharded with each other. So think of it like you have two independent chains, and then the validators agree that they move sub pieces of each state into one virtual shard. And then in this virtual shard, that's now the two validators promise that like they won't violate any of the actual constraints in the chain. So now you can have synchronicity, within just for the block trade. The nice thing here is that it's, again, determined by the actual economics of the system, i.e., only if users are willing to pay for it do you get a sharded system. If no one needs this, it doesn't happen. Like, it doesn't happen by default. And so, like, in ANOMA, you really only get what you pay for. You don't get free global state for, like, without paying for it, because that's a waste of resources. So yeah, this is how you prevent double spends. If you're really interested in this, by the way, please check out the controller paper, which I'll post in the chat in a sec.
Please do. And glad to report that there's a very active chat. I wonder, John, if you want, let's just feel free to hop into questions. And John, you can start. There's another couple around Intense. I can kind of fill in as needed.
Sure. Yeah, I tuned in a couple minutes late, so I was worried I had missed this, but I've seen this term kind of thrown around, the idea of the intent-based systems, intent-based protocols, and I haven't done enough of my homework to really get a hold of what the term means in this context. So I wonder if we could take a bit of time to just really clearly define that and unpack a bit of what it means and what its implications are.
Yeah. And if I can add just a note, this I'm sure Adrian will get into, but Adrian in the past has expressed a beef with the common refrain about intents, which is that intents are just limit orders. But it's, as you can tell by his sheepish look, not necessarily the case, especially for generalized intents. But we can talk about why people might think that, maybe, Adrian, and then why they're wrong.
Yeah, I mean, so limit orders are a specific subset of generalized intents. And why does everyone think of limit orders? Well, because like 99% of the use cases right now involve trading. So like to most people, these systems really just look like, I don't know if you know interactive brokers or Charles Schwab. Like I think like most people that sadly nowadays interact with crypto just like think about logging into the broker. And yes, if you only ever log into your broker, you think in limits orders and market orders maybe. But when you think of generalized intents, what are generalized intents? It's just a little bit, it's a piece of state update, i.e. I currently hold A and I'm willing to hold B if and only if certain conditions are met. So it's a piece of state. And then you may have some code that expresses some extra constraints. For example, I'm willing to trade A for B if the weather in Paris is nice. Or I'm willing to trade A for C if the weather in Paris is nice, but the weather in Switzerland is bad. Whatever. You can essentially configure this. But the important thing is, it is fully arbitrary. An intent does not know what a price is, what an asset is. It just knows there are Merkle trees and they have state keys. And you are transitioning state keys and you're trading or you're moving the state keys around. And so you can build whatever you want. Like you can build very complex, for example, like NFT exchanges where you swap 2 blue CryptoKitties against, I don't know, 1 CryptoPunk. Whatever you want. And like this is the important thing, this is not not fixed by the developer. Or like not fixed by the protocol architects, it's called this way. But rather like developers can then sort of like take generalized intents and specify them down. And the super nice thing about generalized intents is that they're composable. i.e., and actually this is like a little bit of a technical deep dive into how ANOMA does it and like how ANOMA, the ANOMA resource machine, really fundamentally differs from sort of the traditional virtual machines and why it's an intent machine. In ANOMA, we care much more about the state layout rather than the execution trace, right? Like when you think of the EVM, you specify an execution trace. You specify sort of the order of operations and how they modify some part of state. It's very imperative and it's sort of how you program it. You write like kind of like early jQuery, if you still remember jQuery. And ANOMA is much more like React. It's very declarative functional in the sense that you only like specify boundary conditions, i.e. like boundary states, like I'm currently in this state and under these conditions, I'm going to be in that state. And so as a result, you could, for example, take an intent from A to B, someone else has B to C, someone else has C to D, and then D to A, and you can start collapsing them. And like they don't necessarily all need to relate it to the same trading application. Or like, for example, like you can match intents that belong to Uniswap to across to, I don't know, dy dx, you can match all of across the entire spectrum of available intents, rather than being limited to only having composability within specific applications. So you get true sort of like composability across all possible applications. I mean, again, this comes then down to solvers, and solving is then hard if you're trying to sort of like solve for an arbitrary state space. But generally speaking, you could solve for an arbitrary state space, and first person to figure out how to do arbitrary solving is going to make a lot of money. This problem is probably NP hard, and we're pretty certain it's NP hard. So like arbitrary solving is going to be hard. But yeah, this is essentially the intent. And like then you can sort of subclass it and go like, well, some applications may only care about limit orders. And so then sort of like limit orders just fall out of generalized intents for free. But you still get all this composability benefit. And maybe the last point here is with the intents, you can also, since in the anomalous state layout, really it's just all state. You can either attest to the fact that you own some state in a Merkle, like in a ZK proof or in a plaintext signature. The system doesn't really change this much. This is the super nice thing. So as a result, like privacy is not actually a developer choice. It's more of a user choice. For example, if someone builds a DEX, whether that DEX does private or transparent trading is determined by what the sort of end user interface does. Does the end user interface attach a ZK proof or plaintext signature? And you can still match across these two things. Like you don't split all these things apart. You're like, oh, this is the private DEX and this is the transparent DEX. It's like, it's just all intents. And some have ZK proof, some have signatures, some have different kind of signature schemes. It doesn't matter. They're all just composable with each other.
Yeah, this is good. I'll add what GPT helped me to understand here, and it's maybe a more simplified version, but I've in a previous talk I heard Adrian describe intents, generalized intents, as the outsourcing of compute, and the idea that like I just say I want something done, and these solvers come and help me do it. And instead of me having to like worry about gas or signing, or we sign, but then effectively everything else goes to the solver network. I'll leave that at that. The point you brought up about arbitrary solving over kind of like a n-dimensional space, and then generally what seems to be, I might be wrong, but what seems to be the problem right now is like incentivizing solvers across non-financial use cases. If you would agree with that as the current state of the problem, it'd be helpful in the spirit of like learning, and like to your point, like people haven't figured it out. We always like to find these like edges where it's like kind of like a bit of an open research question. And it feels like incentivizing solving generally is worth jumping into.
Yeah. So yeah, actually, whether your comment on like solving is essentially outsourced compute. It's exactly correct. Because instead of me finding the best route to like get me a hotel and a train ticket at the same time, I just go, I want this solver, please, under these constraints, solver, please make it happen. The nice sort of property of this is that this also means that like it maps really well to doing, for example, ZK proofs. If you just like, I have some data and I'd like to be compressed in a ZK proof, please do that for me. So like generalized intents generalize very nicely to essentially all the problems we see in terms of blockchains right now. Sort of the incentives for solvers are interesting. I can start with the technical, like technically it is fine. As in intents can carry fees. So like essentially you can think of this as an extra output in a UTXO that is only claimable by the person that settles the intent. It's like I have A for B and a small fee, and then if a solver settles this because they managed to satisfy my intent, for example, they found another intent that was B for A, they can claim that fee, and that fee is only claimable upon settlement. This has a super nice property that I never have to worry about gas. I never have to worry about which specific fee currency I'm paying, and as long as the solver accepts whatever fee currency I put, maybe I put the NFT as a fee, you could. Of course, the problem is this means that not all intents are settable. I mean, this is generally true anyway. But like, for example, I may want to write an intent that says, get me this rare flower from the Amazon. And here's 1 cent. No one is going to do this for a cent, right? So like this intent will just live forever until it expires. But also on the flip side, also means I can say like, you get 10 grand if you get me this rare flower. And then this 10 grand is only claimable upon actual delivery of the rare flower, which is the super nice property here. But this is sort of maybe the actually very important thing to understand about generalized intents. Not all generalized intents are settled. Some will just never be settled, right? However, of course, not all solvers will work with all intents. And so it becomes a little bit of a cold start problem. Like, solvers are going to start tackling the easy markets first, and then fees are going to compress very quickly. And we're already seeing this roughly with market makers right now. Market makers spend most of their time on like the BTC ETH pairs, BTC USDT pairs, you name it, the super liquid pairs, but fees are tiny as a result. So as we go out onto the sort of uniqueness spectrum or rarity spectrum among digital assets, the spreads widen because not many solvers do these kinds of things. In terms of incentive compatibility and incentivization, actually, I think one of the big benefits of ANOMA is that it standardizes the architecture. That it is really the same to do this for BTC ETH as it is to do this for like some essentially like complex Kauswap thing. Like roughly like the infrastructure looks the same because the intents are all formatted the same way. You may have to adapt to solver algorithms, but generally like the barrier to entry goes down quite tremendously, which I think will massively help broaden the space. Personally, in the short term, I am not a huge fan of subsidizing solvers. And we've seen this with like Kauswap. And I think the problem is that solvers are like the only business model in crypto that actually makes money because they actually provide a valuable service. Like if you're good at like running compute on behalf of other people, you make money. I mean, most people don't think of market makers this way, but really, if you wanted to also be super efficient yourself, you could also just like only submit taker order. Taker orders on maker order. No, maker orders, not taker orders. This way around. And so like do a bunch of compute yourself, but you go like, well, I'm lazy. Here's my market order. Someone else deal with it, please, right? And so this is why I don't really like printing inflationary rewards, for example, to incentivize solvers, because I think it warps the economics quite a bit especially like at the moment, whether we can do like retroactive public goods funding for solvers, like essentially like because solvers become a huge part of the ecosystem, so you drop them tokens later on. That I'm much more open to, but sort of like on a per order basis to like subsidize solvers and incentivize solvers. I don't know. I think it warps the economics quite a bit.
Cool. Some good ones in the chat. I feel like maybe we just get into it. Thank you, Adrian. I mean, I have more on like the resource model, and maybe Acacia can help us with that because I know she's thought a lot about it. She's in Intense Initiates Cohort 1. There's a couple of kernel folks
Nice.
Who are there. But what if we go into the chat? If Afika or Steph or Oliver or anyone, just feel free to chime in.
Kind of global reserve currency. That's an interesting topic.
I'll jump in real quick because I was about to comment on your last point, Adrian. Hi, I'm Oliver. Which is what you were saying about, the inflationary dynamic of a per task payment. As you were describing this, I kept thinking about this platform that I used to work through that was like a translation marketplace, and people could be like, hey, can you translate this document for me? I'll give you $20 or whatever. And it's like, well, who's going to accept this job? What's the, how desperate are you, or how willing are you to, that kind of thing? Because a lot of the time the money wasn't great. And the translation market overall has always been a race to the bottom for this reason. People always don't want to pay for it. And so like I can imagine intense markets being a race to the bottom and finding a sort of very dog eat dog way to fulfill things that wouldn't necessarily be great for the people working in it or the people receiving the service at the end of the day. So I agree with you that
So-
that could be problematic.
Yeah, I think it's less like because like when you sort of like do a translation, right? The outcome is a lot less specified. Whereas if you like want to trade A for B, the outcome is well like you can constrain sort of the sort of the performance of the results essentially much more granularly, which I think makes this better. At least sort of for actual end users. Whether it's a good idea, like whether it's super fun to be a solver, I don't know. Because again, like the solvers compete in the race to the bottom. However, I have to say, the one interesting niche that I've seen in the real world as well is the long tail is way longer than most people assume. And I think actually like most like the BTC ETH market, yeah, Wintermute is going to dominate you there. But like the random ass currency that has pretty low volume, I mean, that's a great market essentially for new solvers to begin with, because you don't compete that much on speed or performance. You actually compete on that you're willing to serve the market. And actually, DevCon is a perfect example here. So I flew to DevCon and was like, I should get some Thai baht at the airport in Frankfurt. And so I went to the kiosk, not thinking about it. Like, it's like, just give me $100 kind of a Thai baht. And they gave me some money. And then I looked at the receipt and the spread was 40%. I was like, holy fuck. The real world has huge edges essentially that solvers can go in the long tail here. So I think like for solvers it's nice and like, but I agree with you. It's like you have to be very careful on how you constrain what is an acceptable result. If you constrain it too loosely, you just end up in you just get subpar results. You shouldn't, you shouldn't just hope that the solvers will do the right thing. Even though there's some interesting metrics we thought about around like reputation-based systems, so that you can use solving, but also with market orders, where essentially you say my intent is only solved by these three solvers, by the three solvers in this list, and the list is ranked on how much surplus they return in comparison to some reference price for the trade. And so if you steal someone's money because they filled a shitty market order, you immediately get deranked, and that way you lose access to the order flow. I don't know, there are some interesting things with reputation-based systems I think one can play with.
Um, anyone else? Afika stuff. Afika, go ahead, please.
Hi, Adrian. I was curious to know the relationship between scale-free and being topology agnostic. Like, to me, it seems like topology agnosticism fits under scale-free. And if so, are there like other factors you guys had to, or like dimension get to consider to make your guys' network scale-free?
I see what you mean actually here. Yes, this is true. So the fact that Anoma is topology agnostic makes it scale free. In the sense that like it scales how humans want it to scale. Like again, if everyone wants to be on Ethereum, so be it. Then you're constrained by sort of like state space on Ethereum, and we can then start optimizing this. But sort of very fundamentally, we are going to be constrained by requiring global state on Ethereum. Are there other aspects to scale free? No, actually, I mean, not very fundamentally. I think like this fact that the protocol is topology agnostic is sort of the main component. A lot of the other things like privacy, for example, they help. But it's like not fundamental to it. It's more like Anoma scale free because like in the worst case, we can run 7 billion Anoma instances and everyone on their own phone is an Anoma instance. And actually, honestly, to me, this is the dream for like one funky technical reason, which is currently it's very weird that like I have to use an RPC to call Ethereum. Like I'm not a first-class citizen of Ethereum, essentially. Like I can read and write to it. It'd be much nicer if like my intent and like all my connections and all my requests for data would run on exactly the same P2P stack as all the other Ethereum nodes. And so Anoma is very much designed this way that like your phone is just designed to be a one-on-one blockchain, and you own some state, and like that blockchain owns some state on Ethereum, and it owns some state on global Anoma, it owns some state on like your local system. But like fundamentally, it's like there's not a huge difference between you as a user and a blockchain. Just like there are hundreds of millions of blockchains, and just everyone talks the same protocols.
Amazing. Thank you. Anyone else? Can go to Steph if you'd like.
Hey Adrian, thanks a lot for your presentation. Yeah, I wrote 2 comments, but it's from a kind of, I'm very new to Web3, so I don't have a lot of like technical knowledge. I'm coming from the arts field, but like looking through the documentation, I kind of started to have a kind of vague idea of what this intent machine is. And then through my own project, I'm like thinking about which kind of stability can be created on fiat currencies. And thinking also about like devaluation of dollars and how could actually the intent machine be applied for creating some kind of stable value between persons.
It's an interesting question. So the first thing that comes to mind is things around credit clearing, essentially like where rather than trusting this arbitrary version of fiat that like some government says is true, which honestly, like if you use Swiss franc is totally fine as an option. Like I mean, I trust the Swiss government and I like Swiss franc as a fiat. I just actually want it on chain more. Right, like there's nothing inherently wrong with fiat, but sort of like if you want something that isn't dependent on state power necessarily, I think an interesting approach could be to sort of track, essentially give people credit lines. I.e., I pay, like Vivek gives me some X, and rather than transmitting this, I pay this. I just have now a sort of debt to Vivek. And then you can start seeing these graphs form. And if you can then start like where Vivek has some trust graph, and then rather than having to move money around, you just start clearing along the trust graph, right? Like if someone owes me money, like if I did something for Vivek and someone else, Vivek did something for someone else, we can start clearing this directly without having to actually move money around. And maybe if you can then start tokenizing these things, that would actually represent actual economic flow, right? Because this system would then represent economic flows. And then if you can start tokenizing this, then you aren't stable relative to some like fiat currency. You are stable relative to the economic flows of the system, which is, if you're a large system, that's kind of going to be very stable, especially it's going to be stable for the participants within that economic system. I mean, honestly, fiat kind of used to work this way. It was like fiat was like representing the US economy or the US economic system. It has become very weird recently. So this is less true sadly nowadays. But so if like you could go back this way, I think that'd be very interesting. Yeah.
Very cool. That reminds me of Cycles and some of Ethan.
Yeah. Exactly. Cycles is doing great work there. And also what Martin is doing at Circle.
Yeah.
Yeah. Martin Kappelmann with Circles. Circle. Yeah. The names are too simple. Cycles and Circle.
We I don't mean to put Acacia on the spot, but we have somebody in Intense Initiates here, and there was kind of like a broad question of the things, Adrian, that you're excited about. But if in the process, Acacia could share Concordance and some of the work she's thinking about and how she's thought about Anoma, maybe there's a good back and forth to be had there.
Yeah, I'll just kind of give my, because between the office hours, the fireside talk that I gave, and like even this conversation, I think there's a lot of through lines with like, if we all can kind of agree to zoom out and look at everything in blockchain as a split between state machines or protocols. What Anoma does really well is recognize that all state machines are basically doing the same thing. they're defining state, and then they're defining how the state moves around. And so NOMA kind of like wraps around that idea and says, well, let's just call state a resource. And everybody wants to move resources across other state machines. And those state machines don't know about the resources of other state machines. So like a bridge does a one-off job of saying, well, we'll bridge your ETH to base, and in the process we wrap it. But when you kind of put an interface around the entire idea of a state machine, then you can do things like what Oliver called out in the chat, where you kind of like, you don't need to say like, okay, I'm going to bridge from ETH to base, and then on base, I want to do this, but then I want to use this app that's like actually on ARB. And then so like, instead you just say like, I have this ETH and I want to do these things. And the solver like intent machine finds the best and easiest way based on all the aggregates. So you're not having these like liquidity pools over here and these bridges over there. It's like, it kind of takes all that infrastructure and puts it into like one layer. And so you can like move the way you want through that like layer on top of all these state machines. And then the whole idea of concordance is also, to Oliver's point in the chat, where like if you zoom out even more, you realize that every protocol is sort of defining what, like if you look at an Oracle says, we will take some data and make it available in some format for some blockchain. And like the reason why I want to build on top of ANOMA is because ANOMA says agnostic of any blockchain, I want to be able to move state around. And I say, well, state, whether the state lives on chain via like grabbing it through ANOMA, or the state lives off chain via user IO, it's all state. And people mostly just want to define how state interacts with other state. So if my gameplay creates some state that says I like won something, that state should be able to interact with on-chain state that says that game has like points or like tokens that you receive as a result of that. So it's just like, I'm kind of doing what ANOMA's already doing with this idea of like creating an abstraction over resources. I'm like, well, state is also abstract. And then when you have that system, you can define an entire application by saying the application cares about this state from the client and it wants to change the state on chain. And then ANOMA does the hard work of actually figuring out, okay, if that state exists on chain, like these are the ways I want to connect it through the system. So I think this is like the first time where something is very comprehensive and considering how people actually want to use Web3, instead of just saying like, I'm going to come into this market and define this solution and we're going to be best in this solution. I think this is like a very full-fledged like answer. So that's why I think.
Yes, actually, you summarized ANOMA perfectly. It's all about state.
Yeah, exactly. It's a
and,
very
yeah, in the end,
elegant
it very much comes down to this. It's all state. The one thought I just had while you were talking is one thing that what people need to be careful with when they think about sort of like these abstract systems is ANOMA does not give you like best execution guarantees. If you sign shitty intents, like i.e. like a shitty limit order, you will get filled at that shitty limit order. ANOMA is very much, it's like Linux, there are no guardrails. Guardrails really come in the application layer on top. If you want guardrails, like when you're rejecting against shitty limit orders, this is sort of on you, or on the application developer. Yeah, people tend to get this confused. But like ANOMA is like a specific execution environment. It's like, well, it's this abstract system that doesn't really know how to protect someone from like a high slippage. This is an application concern.
And that's the, like, yeah, at the application level, you can sort of define through like an interface of like, these are the intents we want to allow you to do. So you put some guardrails, like ultimately somebody can go outside that system and do whatever they want and send a shitty intent. And then, you know, like they could accidentally drain their wallet or something. But like, yeah, the idea is that you can add those guardrails if you do so choose via your application that you're enabling on top.
Yeah.
Wonderful. Yeah, I've been really interested in Acacia's work as it relates to tokens not necessarily being the first class citizen and moving towards resources. I wonder, yeah, just the follow up there for intense initiates and Adrian, as you think about like what you are excited about seeing in the first group, but in general, what you're excited about seeing built. General question, but just what has your attention as like things start to build?
I mean, so like my dream for someone to build this is actually, it's a multivariate order book exchange, and this sounds very fancy, but essentially just it's a private DEX. It's the ability for you to say, I would like to trade A for B, and someone else goes, I'd like to trade a CryptoKitty for a CryptoPunk, and like every new intent essentially creates a new dimension, a new market in the order book. And like when you think about this graphically, like a cube or like an n-dimensional cube or even three-dimensional cube, you can like, the matching isn't you'd like try to combine things within a single plane, but you rather sort of like go through the cube and like to find all the things that actually match, and then you match orders this way. And you get full privacy as a result, you get like locality as a result. I think this would be hugely helpful for crypto as a whole because it's going to defragment the market overall. I think that's probably the thing I'm very excited about. Yeah.
Can you talk why defragmentation? Why would that? Just because everyone would choose this with better properties?
Because right now it's like you have no composability between no app level composability between the trade sent to Uniswap and the trade sent to CowSwap. And this is really stupid when you think about it. Like those two applications, they both live on Ethereum, and for some reason we have no composability over any of the order flow. So like they're all like liquidity draining from each other. And with Anoma, especially with the P2P layer, all these intents can just live in the same intent network, intent flow, essentially. And so then solvers can just go, okay, what are the three things that combine the best? I mean, the downside to this is it removes like the Uniswap proprietary order flow. It's a downside for them, essentially. But like for users, there's this huge surplus because you aren't sort of like, you don't have to pick anymore like, oh, this thing is more liquid for this specific asset, or that thing is more liquid for that other asset. Or that thing provides you some basic privacy guarantees. You just have like one unified trade interface and go like, I want to do A for B and I want to do privately, and Akasha does B for A, but does it transparently. And like that liquidity combines now.
It's like you can connect the liquidity pools together and then like over those liquidity pools decide how you want to move things. So you're not stuck with like fragmentation in one place, which is where hacks happen anyways. Like the hacks are never at the state machine level. It's always at that protocol level where people are like hoarding money essentially, or like, creating these marketplaces and then like the money just sits there in pools.
Yeah, actually, this is the other really important point. The nice thing is this also gets rid of, I mean, like AMMs are nice and I'm glad we have them, but they're also like the stupidest but best working answer to the problem of counterparty discovery, right? Like when you think of what an AMM is, it's like, oh, we had no infrastructure to do counterparty discovery for like Adrian and Vivek to meet to trade with each other. So rather we did this like global piece of state where we all trade against the global piece of state as our point of counterparty discovery. So now I keep paying for like global access to global state. We're fundamentally bottlenecked by it. Rather, I like with intents, I can just say I'd like to trade A for B, and Vivek says the same thing, and then Solver picks this up. Like I hope over the long term, actually, we can move away from the AMM design, except for like the super long tail of assets, which actually, to Akash's point, gets rid of a ton of honeypots because not all the money sits in like these central places. This is a bad design, if I'm honest.
That's funny. Yeah, that's really good. That's really good. It reminds me, I mean, like it's the new, there's more questions in the chat, so feel free to come in. But the new brief, it really goes into Flashbots world, and like Andy, who wrote it, had been doing research at Flashbots, had been talking about this like, I remember a section where it was like, it was alongside Ethan's work on cycles, which also is a bit critical of AMMs for good reason. And then this idea that like RPCs are temporary solutions, and these like honeypots are not what you want. You want, I think the suggestion is you want things like strategy proof computing. And there was something about information, like just, I'll have to come back to find it, but this brief, it's really one of the more complex ones in the syllabus. But just
actually, this fits really well. Actually, I think I know you on information sort of exposure. This fits in really well with Philip's question.
Okay.
On how do you prevent exposing intents to front running, and like how do you prevent this information leakage? So one of the nice things is that with intents, you can just like completely fix your outcomes, i.e., like you are trading A for B at a specific price point. And if you are signing this, I do not consider that like if the market moves while this is being in flight, you're not really being front runner, just the market moved away from you. So like I know there's nothing we can do to prevent this kind of thing, like where like you have multiple market prices, right? Or multiple venues where prices appear. And so like you can't be synchronous to all of them. If you want something like this, you need to be more cow swap style, where like you encrypt all your trades or your intents. Then in the state machine, for example, on Ethereum, they get totally ordered. Then the normal validators decrypt them. And then sort of like you do cow swap, essentially fully decentralized cow swap. But yeah, there's like nothing fundamentally, like if you send a shitty limit price, you will get filtered this. And honestly, I wouldn't consider this front running. You just like signed a stupid thing. The other thing is, due to being topology agnostic, you can decide who you broadcast this to. So you can pick much more your trust preferences. And like they can change over time in the programmatic in nature. So like when you send your intent, you say maybe for the first 2 minutes, I only send it to this one trusted guy because I know him from high school. And then I do free for all broadcast. Thereby you can essentially for the first 2 minutes go like, I trust the guy, and maybe then you replace this with another one that's slightly more constrained. You can also do like this RFQ style system where you like ask for codes. And the biggest thing, if you don't want to get front runners, you want to do simple solving, you can just do it yourself on your phone. Like if you just want to trade A for B, like ETH for Bitcoin, liquid market, your phone just taps into the intent gossip network and grabs the counter intent to you. And then you like take that intent, combine with your own intent without ever having gossiped your intent, and just directly settle it yourself. Caveat, this only works for simple trades, like simple intents essentially. Like if you have to do lots of compute, it probably stops working on edge devices.
super solid, super solid. So much has been covered. It feels like it's almost worth taking a quick pause. But Adrian, do you have anything that, you know, it's like if there's a pausing question, if this module also it encourages this like continuous learning, and I can tell like just by the way you talk, it's like you're just like finding all these like edges of possible research and kind of like poking your head into those areas. But maybe if you could just go into your own process of like how you think you've gotten to this position where learning in these domains is becoming a bit more natural.
Yeah, I think about the sort of an overarching question, like not a specific technical question, right? Like, but so I approach most of the things I do from like the World War III perspective. I got into blockchains because I wanted coordination infrastructure that survived World War III. And so I look at the lenses I look at the world through that kind of lens. And that sort of just ends up leading me down to like, we need sovereign systems because I don't think the satellites and the fiber cables will survive the onslaught of World War III, right? So you need systems that don't require global consensus. And so I think like, as a result, I sound kind of crazy because I think a lot about sort of like worst case scenarios, like on the eve of World War III, all fiber goes away, most satellites get shot out of the sky. And like most available international bandwidth is not going to be used to like transfer Bitcoin blocks. It's going to be to do essentially coordination, like target coordination. And And so like then the question comes, well, how do I keep like my local community running? And then the answer becomes, well, we need something that like works locally. So like I think about this very much as like, yeah, I tend to think like not of specific technical problems, but like rather like what's the social problem that we're trying to solve? Like, and this is also like the way I approach privacy is like, I don't think about privacy as like against the nation states. To me, it's community defense. Like, I don't want the Zoop financial data to leak to China. That seems like a bad idea, right? So like, yeah, this helps me at least to not get down to like the specific, like the technical thing, more like, what are we actually trying to do here? And actually, I would encourage everyone to do this. Like, I feel like we should think much broader than like, oh, we would like to do slightly faster Bitcoin trading. I don't know. Like, to me, this sounds incredibly boring. And I don't like also like not that useful in the grand scheme of things. Like, we should like be way more ambitious than like, oh, we can now issue shitcoins at a rapid rate and trade and dump them onto unsuspecting strangers. Yeah, think about like some social good and like think about like your local communities and what your local communities need.
It reminds me so clearly of what we have from this module on inventing on principle, as from a
Nice.
man named Brett Victor. And he says, this is about a way of living your life, which most people don't talk about. As you approach your career, you'll hear people say, follow your passion or do something you love. This is about something different, finding and following a principle, something you believe is important and necessary and right, and using that to guide what you do. And his principle was defined, and he's done some really cool work on like just like really interesting games and interaction design. Like one of the, he was at Apple for a long time doing that, and ended up starting a school in Northern California. But his principle, different from Adrian's on World War III, but creators need an immediate connection to what they create. And so it's like all of his like computing related work has been on like immediate connection. I think Andy's, if I think about like where the kernel syllabus has come from, has been like, what are more interesting forms of money? Like genuinely more interesting forms of money. And I think that one place that he's gotten is that money and speech are intertwining. And that's why even though like this module is about like he's been working at Flashbots and stuff, like it's been really interesting because like his approach here in this module, this is maybe my last like bigger question, but it would be somehow Andy connected a lot of stuff happening in Flashbots world and MEV to LLMs. And the suggestion being that like it kind of came up in the chat via Afika earlier that like intents also kind of like remind you of how chatbots are being used in some way. It's kind of like, help me, I have this like very specific thing, help me figure it out. And so maybe there's something to discuss there. The question here kind of comes from this section. It says, we're not using cryptography to hide stuff. It's about using cryptography to constrain information available at any given time to those who have committed to using it in the most valuable ways, where that value is both credible and shared on public networks, even as the exact way it is communicated remains private. In MEV research, we measure our ability to do this by asking how much latent financial energy, which is a big Flashbots term, latent financial energy, we are able to capture and use for useful work. What is the equivalent for LLMs?
Interesting. I mean, LLMs overall are an interesting question and how they play out. And like to your point that chatbots, for example, very much look like intent-based systems. It's certainly correct. But not in the way I think most people think about them. I think when people start thinking about LLMs and chatbots, they think they write their request into as an intent and then send us off to some LLM down the line, like somewhere on the internet. Maybe this happens, but I think actually this is somewhat of a more terrifying future. Because when you think of what LLMs are very good at and chatbots are good at, they're good at passing human language into structured data. And so like to me, the much better application of this is the sort of like you have your local LLM on your device, and it outputs intents essentially. Like it transforms like you typing "I'd like this flight" into some actually very specific intents that maybe you can review, or maybe over time you actually just fully trust it. And then the way intents are used is that they are used as the fabric by which different chatbots negotiate with each other, because they're not going to negotiate in like human language with each other, right? Like you want to have some structured output there where it's like, oh, I typed in that I like a flight, and then like I get this intent as a flight, and then I send this off into the ether. And maybe if you want to do more complex inference tasks, then it looks like I'm sending my intent just actually with natural language, but I send it to something running in SGX or TDX or T. I mean, they're all the same as far as I can tell. And then I sort of get the output back. But yeah, I'm very skeptical of the people that keep saying that LLMs will be there, but will be used by solvers. To me, it seems much more likely that LLMs will be used to pass like human desires into data we can compute over. Yeah. Maybe in that sense, what's the latent financial energy?
I think that's
Maybe
like a,
latent human desire or something like this, like where chatbots output this, and like output intents, and then like solvers try to maximize latent human desire.
yeah.
And
I think I think what it's getting to with this latent financial energy is like Flashbots like comes to the fundamental conclusion that there is always information asymmetry. There is no such thing as like a version of the world where there is zero information asymmetry. And if that is the case, then there will always be this like idea of like latent financial energy. And I do think you have a reasonable corollary you just came up with of like latent intent, where it's like you're pulling out to the right person at the right time what it is that I want to do, and you're helping me accomplish it in like arbitrary ways. Vesta, if you'd like.
Yeah, this thing on latent human desire makes me think of like all of us have a whole lifetime of data about our lives that we probably can't even comprehend so much about ourselves at the moment. So there's probably like a lot we can do with this. Like, I mean, Spotify, the amount of information they have about you and then what they can kind of like tell, and you know, like the other things that you can create after that, like the other order effects. So maybe there's something here. It's like, I wonder if there are any projects out there that are dealing with this, like how to make sense of the information that we have in our music preferences, in our social relations, and how we, you know, the images that we like, stuff like that. The social media.
It's a terrifying amount of data in there, most likely. But I mean, this is I know, terrifying. I think it'd be actually very cool to see, because one thing is like, currently we always live in this world where social media is used as such, is weaponized against us. But you can imagine that if you actually run a lot of this locally, you can use this to slowly modify your behavior in ways that you'd actually like for yourself. Just like none of the social media companies have any sort of intent, like any desire to do this. By the way, for people that want to get inspired on this, I can really recommend, I don't know, you should read Neil Stevens. Especially like if you're interested in the LLM stuff, read The Diamond Age Princess. He essentially predicted the entire thing. And if you're interested in sort of like world economics, read Snow Crash, and then read the rest of Neil Stephenson. I don't know, the guy seems to have been right. I mean, he essentially, The Diamond Age Princess talks about the fact that it's from 95, and it talks about how a little girl picks up a book that responds to her with like customized learning opportunities. It's such like what the LLMs are going to be, hopefully, eventually, where it's like your phone is your local teacher that just knows what your weaknesses and strengths are, and you just feed it like with your overall goals.
Really good stuff. I mean, Adrian, just thank you. It's been a big pleasure. Um, one quick one in the chat from Justin, if you'd like it.
No, 2 weeks, I think. Yeah, I'm redoing it.
Back to pink.
It's been a while. Yeah, no, back to full red.
Full red. We caught you in an in-between.
Yeah, no, you caught me at the tail end. I mean, like right now it's not even pink anymore.
That's true. That's true.
The problem is like, unless you catch me like in the first 4 weeks after I do it will pink. Because like only for like 4 weeks is it actually full red and sort of like this descending gradient.
We have to really time our next invitation. I would balance some of the Stevenson work with, I've been reading a biography of Tolkien, and I think that a lot of the work in Lord of the Rings, it's really like the story that I like to balance a lot of the sci-fi work of the 90s and 2000s. There was a conversation with Glenn Weil recently where he worried about a lot of the dystopian outcomes that have come out of the science fiction writers at kind of like the tail of the century. And I don't think Tolkien, Tolkien doesn't even think Lord of the Rings was allegory. He kind of just thinks it was like reality. And I think there's something about it that really ties to just the value of a struggle, like of a kind of like an honest struggle that everyone has in their own life, and that represents a big part of our story. And my favorite part from Tolkien's work that I think is really succinctly emphasized, and I hope this isn't a spoiler because I think everyone has probably seen some part of Lord of the Rings by this point if you wanted to, but a big like theme is that there is no hero in the Lord of the Rings. There's only like giving back the evil that doesn't belong. And I think that this suggestion that like the best we can do is give back the evil that doesn't belong to us is a really interesting way to approach both life and distributed systems.
And you've actually convinced me maybe I should reread Lord of the Rings.
There's some good stuff there. Any like final thoughts, considerations? Anyone who'd like to share?
Adrian, I noticed that this was probably one of the more like where the room was most in sync with the speaker. I don't know how to explain it better, but it was one of the most like attuned firesides I think we've had so far. And I noticed something that a question to me that is kind of light, but like I noticed that something about what drives you is like in response to protecting the community, in response to maybe some wariness or fear around what could happen as a global system, or I wonder like from that place, like what is the thing if you could name that fear, but also name the thing that like drives your hope, that could be really interesting as like this kind of spectrum that you operate on.
So, I assume a lot of people here are Americans. And so there's one huge difference between sort of the American preppers and the Swiss preppers. The American preppers seem to be all about like living off the grid in remote housing, with lots of guns and water and food. And to me, this has always struck me as nuts, because generally humans don't do super well in isolated settings due to essentially skill shortages. You like if you're really worried about shit hitting the fan, you should rather figure out like the 100,000 people that you could tolerate living with, because you want to have at least some doctors with you. And yeah, this is like the Swiss preppers are much more like they're actually like, this is why I think a lot more about community defense. Like to me, it's not like You want to have censorship resistant money in the middle of the woods. That's fucking pointless. Like you want to have like stable systems that can detach essentially from the rest of the world as much as possible. I don't know where it comes from though. My hope though is, I mean, like, I think this is honestly like much more like humane. Humans don't do super well in like in digitized societies, in the sense of like, I think most people, and there are some exceptions to this, but like most people are a lot happier if they have strong social support locally. And so, I mean, I grew up in a village of like 3,000 people, and I still enjoy it to this day. But like, I think so, like this idea that we just all want to be like purely digital beings and have digital communities, I mean, it's nice. But I think sort of very fundamentally, you need also people around you that you like. And I think a lot of the work actually the blockchain space has been doing is like helping this tremendously, because like if you look at the legacy systems, like none of these systems, like none of the Swiss financial systems going to survive a dedicated onslaught by China or Russia. Or fiber cables going away. I mean, like these systems were built in the 60s and 70s. It's ridiculous to assume that they're anywhere near secure enough to run. So this is why I'm pretty hopeful about it. And I think it actually, for lots of people, will be healthier. Like being in the digital void all the time is kind of like terrifying, I think, and not super productive for most.
Please, Philip.
Thanks, Adrian. Noma is clearly a fascinating project, and Justin's question was the perfect segue. Your answer was the perfect segue to the context that I obsess with it to a certain extent. I work at the intersection of AI and Web3, and specifically with a focus on how human identity is poorly served by digital identity. And one of the misconceptions I think that dominates our industry is conflating or confusing information security for privacy. Privacy works differently to how technologists think about information security, but us technologists always say privacy when we really mean information security. And that distinction really comes into its own when, on conversations like this, when we've moved beyond the binary of state, citizen, or corporate consumer, when we are contemplating those communities, those holons that you've just described, the fact that we are each the sum of our relationships, we are people through other people, then making sure we do understand the difference between information security and privacy is mission critical if we're going to develop pro-social systems.
Yeah, fully agreed. This actually just gave me something to think about in terms of like, you know, digital identity systems are, passwords in itself are kind of weird. I mean, you can say like, well, countries are small enough, maybe they still know their people well enough. But like very fundamentally, the people that know me best are essentially like the 95-year-olds that live in my village, in my home village. Because like they've seen sort of the entire evolution over like decades, right? Like passwords are a really weird abstraction, and they work at some scale, like small countries like Switzerland may be still able to do it, but like at a scale of Germany, I don't know, 80 million people, passwords just like become this arbitrary piece of paper that like means very little in practice in terms of the human. And actually, this is why I'm pretty hopeful that digital identity systems and blockchains can be way better, because they can map much more closely to sort of like the actual notion of like human connections, and like you are the sum of your human connections. Yeah.
I'm less optimistic than you might be based on the current status quo, but I am optimistic about what we might do together.
So the nice thing is, okay, the other reason why we should be very optimistic about this, about where we're heading, is we have won the regulatory battle. Like essentially, we have gotten to a point where we out-innovate faster than people can write laws. This has generally been true for the last 20 years or so. But like we are clearly on this accelerating pace of like, how quickly can we ship tech? And generally speaking, like no one can write sensible regulation anymore at a pace that keeps track with it of the tech. And so like they also can't write dumb things. So like in the end, I think if we build, in the end, the things that will survive are the things that actually get like that people want to use. Of course, we should hope that we aren't all stupid and we choose the wrong things, because then we end up very quickly in a pessimistic, terrifying future. But we have the chance as a people to pick a very bright future, because essentially we can build the tech faster than anyone, that we can adopt the tech faster than people can try to prevent it.
Yeah, I think that's a point well made, although I would be concerned that perhaps under-regulation is more threatening than over-regulation. And I guess we're on the effective accelerationist versus defensive accelerationist sort of conversation here. I mean, we all talk about being stuck in traffic. We never say we are traffic. We all jumped individually onto Facebook, but does that mean we're each individually responsible for the undermining of democratic process? So at some point, the people who design the systems have an ethical responsibility for sure.
Yeah,
Alice and Bob and Charlie it can't be left to them.
I've never heard the "we are traffic."
I like that. I'm going to take that. We are traffic.
We are traffic. Who else is traffic? I'll just very quickly, this is from the Duende piece. I think it's one of my favorite parts of the syllabus. It's about this struggle that we described, and I think it's related to what was just described. It says, what we want is a miracle. What we have is a network of messy human beings. You see how these two things are not any different. And Sam talks about Duende, which is an interesting concept. It says, the best among them drag a spirit of revelation up into the room, and when this happens, the duende has been wrested from his den, and the songs that make such revelation possible in the first place are always, always about struggle. They are always a kind of serenade to the resilience and the resistance that struggle creates, and offer proof of its success. Here's another way of singing it from another poet, Antonio Machado. It is good to know that glasses are to drink from. The bad thing is not to know what thirst is for. I really like that part. But in general, like Adrian, you've taken us through such depth and topic to topic in a way that still feels kind of like a knowledge tree. Feels like we can kind of like see where it's come from and where it's going. So thanks for being with us. We hope to have you back with red hair at some point in the future.
Of course. This was amazing. Thank you so much for having me.
Take care, everybody.